Hey, come here. I know you don't like this. Any student don't like seeing this symbol. This is sword. Okay. The reason is because many students don't really know the rules of sword. So let's take a look at some of the rules of sword and let's still see if you like it or not. All right. Rule number one says the square root of m times n. Now, when it is multiplication, it is allowed that the root, because this root is covering the two of them, that this is for the two of them. But because it is multiplication, it is allowed that the root to be given to each of them. So that's why here we separated root m. Now m is having its own root times root n. That is a law. Then let's look at number two law. We can have it to be, root m divided by n. What do you see here? You still see that this root is covering the two of them, and this is division sign. All right. It's still allowed that each of them will share from the root. That is root m divided by root n. What do you see here? This one has its own root. This one also has its own root. An example, I can have an example here by having root 100 over 81. Then, of course, I can divide it, share the root by having root 100 divided by root 81. From here, you can solve. Square root of 100, this is a perfect square, is 10, then divided by 9. Then from there, you proceed in solving. Then we also have, that does not now mean that if I have root m plus n, will it give me root m? Will I share the root? No. Those are the things you need to know. It's part of the rules. Having root m plus n, but we can share the root here. We can only do that because it is multiplication. But once it is addition or subtraction, it is not equal. That is, it's not allowed to share the root to the two of them. Then what do we now do when we are having issues with addition, subtraction of sword? Let's say we have root a times root b. Now, root a times root b, what do you observe here? This one has its own root. This one also has its own root. Whenever you are multiplying this root, they will come together as one. Then that means a times b is what? ab. Look at this example. I can have root 3 times root 2. First of all, they have the same root, or they are in roots. So they will come together as one. You now multiply them. So root 3 times root 2, 3 times 2 is what? 6. But because they are in roots, so and I now have root what? 6. That is what happened here. Okay, you can see that they are separate also. Then they have the same root, It's just that and I don't want to write 3 times 2 again. It's the same thing. So I can just say what? Root 6. So I can also have root 5 times root 7. That is what? Root 35. Are we there? That is root number 5. Then I have number 6. I can have a times root b. What do you observe here? You will see that this a does not have a root, but b does. So what do we do? Look at it. A does not have a root. A will just, when you are multiplying it, A will just stay on its own. Then B also on its own. No connection. All right. So that will give me A root B. You can see from here. This one does not have a root. This one has. So that gives me A root B. An example, I can have 2 times root 3. 2 does not have a root. This one has. So that will be what? 2 root. They will be joined together, but not in the same place. All right. So that is that. Then rule number 7 says, of course, when we were dealing with root A times root B, we agreed that it's going to be root AB. Now, there is M. There's an attachment of M to this one. Now, mind you, M does not have anything. So, first of all, M will be outside. Then root A times root B. The root can now combine because of the multiplication law here. That gives me root AB. An example is I can have 3 root 5 times root 2. What do we have here? This one has their root. Look at it here. Root 3 times root 2, you have root 6. Root 5 times root 7, you have root 35. Of course, if I have root 5 times root 2, I should have root 10. But with this 3, of course, the 3 will be outside, then I have root 10. 3 is not part of it. What if we now have something in this form times n root b? What do you see here? Now, this one can match each other. They should be outside anyway. And the one that has the root also should match each other. So I have m times n here. This one does not have anything to match. So that's why it's having m here. But now it has a partner. So m times n, because they are both outside, that would be mn. Then root a times root b, that would be root ab. An example. Now, if you have, maybe I have 3 root 2 times 5 root 3. What do you have here? We are going to, this one multiply this. That will be 15. Then root 2 times root 3 is root 6. That will be 15 root 6. It's so easy. Then we also have number 9. I have, these are the breakdown. Okay. Then number 9. What if I have root a times root a? Now, don't forget that when we were dealing with root a times root b, we said because they have roots, we pick one of the root, we pick one root. Then we now multiply this. A times a is supposed to be a squared. So many people will tell you that this will cancel this, correct? It has reason, it's from indices. So then we now have a. That is very, very correct. Now, another thing is this. Whenever you are multiplying the same roots, that they are the same, just pick one of these things. That's all. If I have root 3 times root 3, normally it's supposed to be root 9. Then root 9 is now what? 3. So that's why I said you should just pick one of them as the answer. If I have root pt times root pt, just pick one of this one because they have the same, we are multiplying the same root. So the answer will now be what? Pt without the root again. Please, let's take note of that. Then we have, I can now have number 10. I can have m root a times root a. What do you have here? Don't forget that root a times root a is supposed to be a, because it's supposed to give me root a squared, and the square will cancel that to be a. Then m times that a, that will be what? Ma. An example, if I have 5 root 2 times root 2. Now this 5, the reason I put here is that m does not have anything to, so that's why it's here. So the same thing is available for 5. 5 does not have anything to multiply, so 5 will be outside. Then root 2 times root 2 is supposed to be root 4, and that is 2. So I cannot just say 52 here. It's wrong. There's supposed to be a multiplication. So that would be 5, just like m a, that is m times a. Here will be 5 times 2, and that will be what? 10. So the answer of this place is 10. Then we have number 11, as I can have m root a times n root a. What do you have here? You see that m and n are outside. They multiply each other as mn. Then root a times root a is a. They are the same. That is mna. You can rewrite your own and write it as man. Okay, so that is. Then we have, let's come back to this place. We have not really addressed the addition and subtraction of surd. Whenever we are adding, look at this place. This and this. How do we get this? That's what we are doing. If I have root 3 plus root 2, what do we do here? Because they are not the same roots, we cannot do anything. This is the final answer. But if this one is the same root like this is addition. Now, let me take us back to when we have maybe 2x plus 2x. We say the answer is what? 4x. This s is like the root here. Okay, hold on. Let me start with maybe 5 root 3 plus 2 root 3. Look at this thing. 5 root 3 plus 2 root 3. What do you see here? Just that this one are the same roots. That's addition, please, not multiplication. So whenever we are adding, we need to be conscious of these roots if they are the same. If they are the same, then we can add it. Now I can now say 5 plus 2, that will be 5 plus 2. Then we now pick one of the roots. Look at this thing. So this 5 is 5. Now let's represent this with x. Then plus 2 is 2, x. What do you observe here? They are the same thing. This one two are the same. So 5x plus 2x is what? Is 7x. So that is what is happening here. 5 plus 2 is 7. Then root 3 is like saying 7x also. Okay? The reason we are doing is because they are the same thing. If this one is root 3 and this one is root 2, we cannot add. We cannot do anything. The same thing is applicable for the subtraction. That's I can have 7 root 2 minus 4 root 2. What do you see here? Because they are the same roots, I can operate. I can go on and subtract. So 7 minus, I will just subtract their coefficient. So 7 minus 4 is what? 3, then root 2. Do we understand? So I can also have another one. I can have root 5 plus root 5. Now, if I ask what is x plus x, you tell me it's 2x. Now, what is root 5 plus root 5? There is one here, invincible. There's another one here, invincible. So 1 plus 1 is 2. Then pick one of the roots because they are the same. And that gives me 2 root 5. I can also have this as I can have 3 root 5 plus root 5. What do you see here? This is 1. Then 3 plus 1 is what? 4. Then I can pick one of them as 4 root 5. Then I can also have this. What if I have something like root 7 minus 3 root 7? What do you observe here? This is 1. So 1 minus 3 is minus 2. That will be minus 2. 1 minus 3 into root 7. And that gives me minus 2 root 7. So that is how to approach addition and subtraction of surd. Now, once you know all these things, if you are to now move into surd, it's going to be very easy for you. Many people don't know all these things. If you don't know this, how do you want to learn surd? It's not possible.